Hi, welcome back to Music Chemistry. This is Electron Configuration Germanium GE lesson. Okay, germanium is the 32nd element on the periodic table, so we write 32 for the atomic number. And its atomic mass is technically 72.6, but we're going to call it 73. Okay, so it has 32 protons, since its atomic number is 32, and since it's electrically neutral, it'll also have 32 electrons. So let's look at the number of neutrons. Again, remember that neutrons are AMU minus protons give us our number of neutrons. Pretty cool, huh? So it'd be 73 minus 32 would give us 41 neutrons. Pretty darn snarly, huh? So put a 41 there. But before we do our electron configuration, remember that S subshells can hold 2 electrons, P subshell can hold 6 electrons, D subshell can hold 10 electrons, and F subshell can hold 14 electrons. Also, we're going to use something called the diagonal rule, or the off-ball principle. We start at the top of the slide, and we work our way down until we run out of electrons. So let's go ahead and do that. So we have 32 electrons. So we start at 1s, so we're going to put 2 electrons there. Then we're going to go down to 2s, and we're going to put 2 electrons there. Down to 2p6 and 3s2. So we got 2p6 and 3s2. Then we come back up here to 3p. And then we're going to also go down to 4s2 on this one. So it'd be 3p6, 4s2. Pretty darn snarly, huh? And then we're going to get 3d10, and we're going to stop at 4p there, so 3d10, 4p2. So if we add those up, 2 and 2 and 6, and 6 and 2 and 10 and 2 make 32 electrons, so that looks good. So remember that Hund's rule says they have to put an up arrow in every suborbit before you start the down arrow. So 1s, up and down. 2s, up and down. 2px, 2py, 2pz, and we start our down arrows, just like that. Pretty cool, huh? 3s, up and then down, 3px, 3py, 3pz, and we're going to go down, down, and down again. 4s, up and then down, 3dx squared minus y squared, up, 3dxy, 3dyz, 3dxz, 3dz squared, and we start our down arrows for those. Pretty darn cool. I like it. Alright, so now, what about our 4p's? Now, we only have 2 electrons, so we go up arrow and up arrow. Now, what about our noble gas notation? If you look on the periodic table, you notice that the nearest gas that's noble to germanium is going to be argon. You can't use krypton because that comes after germanium, so you have to use the one before. So it'd be argon, so we're going AR. Now we're going to look at our valence shell. Now our valence shell would include these guys right here. This is our last shell. But now I want you to see me do something here. I'm going to write this in numeric order. So it's going to be 3d10, 4s2, 4p2. Pretty darn cool, huh? Alright, now why do we do that? Well, whoever invented noble gas notation decided that you should still put the 3d first, even though the 3d falls between the 4s and the 4p in the electron configuration using the off-ball principle. Alright, now we have 4 quantum numbers. So germanium is in period 4. So the principal quantum number is going to be 4. The angular momentum, since germanium is in the p block, that L value is going to be 1. And we look at germanium as the second element over in the p block. So you have -1, 0. So the m value is going to be 0. And let's look at this last arrow right here. That last arrow is going up. So that tells me that my S value is going to be 1/2 positive there. Pretty darn cool, huh? Well, that's it for this video. We'll see you back here at Moosing Chemistry.